So Java 9 introduced the Java Platform Module System, JPMS, a mechanism for grouping packages into larger named units and for describing the dependencies between them. A module sits one level above a package, and we know what a package is, okay? Packages group classes, modules group packages. And before Java 9, any public class was visible to every other class on the class path. Okay, class path is just some information of paths where our JVM can search classes. Okay, usually .class files. And this made public too blunt an instrument. Okay, you could not mark a class as public for classes in my own code base, but invisible to the outside world. Modules solve that and several other long standing problems like reflection, right? So by reflection, we were able to accessing private variables as well. So our modules can stop that as well, and we can get truly encapsulation and strong encapsulation, we can say, by modules and by making the boundaries of a code base explicit. All right. Also, we solve some other problems like bundling size. Problems modules solve. First one is missing dependencies. Found at runtime when a class fails to load. Found at compile time and module resolution time. Java made this to compile time, okay, scenario rather than at runtime. Conflicting versions. Two Java archives with the same class load non-deterministically. Okay, we will see why. Each module is uniquely named, conflicts rejected early. Okay. Now, weak encapsulation. Every public type is visible everywhere. Only exported packages are visible outside the package. Now, monolithic JDK. Apps ship with the entire JDK. And in this one, jlink builds in minimal runtime containing only required modules. Now let's understand more this monolithic and jars. So jars means Java archives, and this one is basically one zip file containing our compiled Java classes. Now when we build one Java application, we package it into this jar file. Also let's understand what is jar hell, okay? Meaning conflicting versions. Suppose we are building one application and we need library A. Let's see here. We can delete this one after that. All right. So let's say we are building one application in which we have one library A, okay, that needs to be version A or version 1, okay. Now we have library 2, library B that needs library A of version 2, okay. Now we have two versions of the same library and our Java gets confused. Okay, which one should it use? And we call this one jar hell. Okay, and before modules, Java would pick one randomly at runtime. And let's say we have some different method signature in this version and some more methods. Okay, and now we are trying to calling. We are expecting that we will get this one, but let's say our Java picked this one, some wrong version, then we will get some mysterious errors or results. And we had also problem with this one monolithic JDK. So when we install Java, we get thousands of classes, okay, for our, let's say, GUIs, databases, networking, right? And let's say we want to ship only hello world, only we need, let's say, 10 classes. Then in monolithic JDK, we had to ship the entire Java runtime, which was around, let's say, 300 MB, right? But with modules, we can create custom runtime with only the modules we need. And then our app could be 30 MB instead of 300 MB. So this is also, so this one was also the big problem with our monolithic JDK. Now, modules do not replace packages or change how you write individual classes. They sit above that layer, describing how groups of packages depend on each other. Okay, we will see one good example. Now let's see what a module is. A module is a named group of packages plus a descriptor that declares what it requires, other modules it depends on, what it exports, packages it makes visible to other modules, what it opens. We will see each one. Okay, packages it allows only reflective access, and this one is runtime. Okay, we will not say reflective in this chapter, but okay, we will just overview that one. The descriptor lives in a file named module-info.java at the source root of the module. So if you have marked any directory sources root, then you can only place this file inside that directory directly. Okay. Anywhere you cannot place this file at any random place. So this is one file that only exists per module. Okay. And you can say one sources root equals to one module. So we will create our own structure, not this one. We will go with two modules to understand things more properly. User service in com.myapp.api is exported. So external modules can use it. Helper in com.myapp.internal is still public in Java terms, but because its package is not exported, this one, we can see this one. Okay. How we can write these instructions in our module descriptor. First, let's create our structure. Okay. And one more thing is, probably you have understood that if we need multiple modules, then we need multiple source routes. Okay. Okay, now let's see. We can delete this directory src for now. We can create modules. I don't think we have much important thing. These are just normal examples. Okay, we can delete this one. Delete this. Now we are good. Okay, so now we have our YT, okay, folder. And inside that, what we can do is we can create module, but this one is our IntelliJ thing, okay? It has nothing to do with our Java module system. So if you create here IntelliJ module, it generates its own .iml file, okay, separate SDK settings and also our class path config. So this one is one IDE level thing. We don't want this one here in our understanding. Okay. So what we can do is we can create here one directory and we can create this one as just a simple directory. Okay, module one, and we can also create in this one more directory which is module two. Okay. Now let's create one more directory inside this src. Inside this as well, one more directory src. Now we want to mark these two directories, src directory as sources root, so that we can work these two directories, module 1 and module 2, as separate modules. Okay. So what we can do is right click on this one and mark directory as sources root, and this will turn blue. Okay. And same as here, right click and sources root. Now what we can do is we can create our packages inside these two directories. Okay. So let's say in this one, right click, or we are not getting here. That's fine. We can go with here. Okay. Select this one and click on this one. Here we can create one package. And if you want nested directory, then still fine. You can go with com. So this one will be one directory, and inside that we want one. Okay. Inside that we want one, let's say, API structure. Now create in this one as well in src in module 2 package. We can create here com.2.api. Okay. And if you have noticed that we have created these two packages with different name. So package names themselves must be unique across modules. Okay. That's why we use some meaningful names. like com.1 for module 1, something like that. Okay, because our module name only appears in our module info.java file, okay, in let's say requires and exports, nowhere else, because Java resolves which module to pull from behind the scenes based on which module exports that package. Okay, and let's say if you could have created these two packages with same name, we call that split package, and Java will throw an error at startup. Okay, it's basically forbidden in the module system. Now, one more very important thing. If we don't create here these files, module info.java in our sources root, then our Java will treat these as packages, okay? And we can import any public class from this package into this one, okay? So let's not do that. Let's see how we can access those. So in this one, we can create one class, that is, or we can create one more thing. Now let's create one more package, which is, let's say, internal. Okay, we want to use that package inside this module only. So in this one, you can create new package, and you can put this one com.1.internal. Okay. Now inside this API, we can create one class that we want to share. Okay. So user service, create this one, and inside this internal, we can also create one class. Let's say helper, and this one is meant for only this module. Okay, here inside this src only, we don't want to export this helper class outside this module. And what we can do is we can write here something. That's fine. Public static, we can make this string. Okay, then format string s, and s dot to uppercase. We can print something just for understanding. Okay, or we can return something internal helper. All right, and we can plus s. So we can return this thing, and inside this user service we can do something public string, let's say get user, and inside that we can return something hello from. Also we can mark this one as com.1.api. Okay, just for understanding. So here we have created two files, one user service. In our API, we want to share, basically this one is API, then we want to share, right? That's why we put here API name. And this one is internal. We don't want to export this file. Okay. Now you can see that this one is one package, com.1.api, and this one is another, right? And we can import this helper inside this. Okay, so let's do that. We can import, and we can use here, you should mark this one as public. Okay, if you want to import, then here we can use helper.format. This one is static, so we can call directly. So we can use this one inside this file. Okay, because they are both in one module, but we can export or we can use this one from here as well. Okay, we will see that. Let's create one file in this one, main. Okay, now let's import here those two files, and let's try to use those. We can import com1 API user service. We can also import com.1.internal.helper. Okay, because our IntelliJ did not showing us this suggestion, because IntelliJ also work on these names. Okay, so if you have mentioned this internal, then IntelliJ would have understood. Now inside this, what we can do is we can create one main method to run this one, and we can create here one object of user service, then print this one. Okay, that's fine. Now what else we can do is we can create, let's say, string as helper.format test. Okay, and we can print here result. S. You can run this one directly from here, or you can run this one from here as well. So Java C, we have to go inside. Okay, so this one is now different. All right. So here what we can do, we can go inside cd module 2 basically, and inside that we can go, yeah, src, then com, then to, then dot, then API. Okay. And inside that we can compile main.java, cannot find a symbol. So this one is very interesting problem because we are only compiling our this main file. Okay. And our compiler doesn't know where our module 1 classes are, right? So we need to tell it via our class path. And this one is also another big problem without module system. Okay, so we can open one more terminal, and from here we can compile our module 1 first. Okay, and that will make sense in a bit. So let's just do. We can compile that, and also we can provide some separate destinations, okay, for our module 1 and module 2. So inside out we can create one module 1, okay, and inside here we can put our compiled files, dot class files. First one is module 1, and then src, then com, okay, then 1, and API. First we can go with user service dot java, okay, and then we can go with module 1, same thing, src, okay, then com, then we have here 1, okay, then here we have internal, and also here we have helper, okay, helper.java. So run this command and you will see here we got here this one, and inside that we got these two files. And if you open this one is dot class file, okay. And if we don't have provided this one, then like usually we could have got these dot class files here, okay, with those files. So we can provide some destinations using our this command, okay. Now let's compile our module 2, and we can put our module 1, this one basically on our class path here. So let's do that, compile, and we can provide some information, class path. If we basically here we are telling if you don't find any classes, you can look out here, and here we can provide some destinations. First one is out dot module, then 1. Okay, so we provided here this destination, right? And this one is just one convention, like you definitely put your dot class compiled files inside somewhere else. So this one is just one convention, out folder, okay. Now here we can go with same syntax like previously. We can provide destination and out dot and module 2, and we can compile here something module 2, and we can go here src com 2, okay, then API, then main.java. Do that and you will get here module 2 as well, okay. And this one is dot class file. Now how can we run this file, this dot class file? We can go with java, okay, simple, and we can provide again class paths, out, then module 1. Now we are getting suggestions, module 1, then here what we can do is out, then module 2, okay, and here we can find com.2.api.main, okay. So without modules, we manually manage our those class paths, and we tell the compiler where to find other classes using .cp command, okay. and this gets messy in our large projects. Okay, so this one is also one of the reasons that our module system was introduced. All right. Okay, now we can run this one and we got our output. Okay, so we cannot run this directly like that. Okay, so overall scenario here is that if you have two packages like this, then and two different directories, right? Like if you have something like this kind of structure, and you will probably have, then you have to manually provide these kind of instructions. Okay, so you can see that here, this helper, we can access this public method. Okay, and now let's say we intend this one to be internal for this module only, even though this one is public. We want that no one outside can access this method. Right now, how we can do that? So for that, what we have to do is, so now let's create our module files. Inside this, you have to create this one in your sources root. Okay, create this one, this file. Okay, and we can name this one com.1. All right, and here we can export. We will see those keywords, okay, in our documentation. Exports com.1.api, and our IntelliJ is not showing suggestion for internal. Okay, even though that could have valid as well, but IntelliJ know that internal means something you wanted to use this one for only this module. Okay, so now we are good for this one, and let's create one module inside that. So you can see here we are not getting any output or any suggestion for our module file. Okay, now will we get any problem? That's the point. So we can create our one file. Okay, let's do that with module-info.java, and we are good. Okay, and here we can write module. We can write something com.2, and we can put here requires com.1. Now what's the problem with this one? Already exists in the module. Go to duplicate. Okay, so we are getting here some problems, like here already exists, and also this one. So if you remember, I have told you that IntelliJ have different module system. Okay, so and this folder YT folder is not any module marked from our IntelliJ, right? So after we created this one, we did not get any suggestion for that because we created this our own. Now our IntelliJ is thinking that we are creating some duplicate. Okay, so we need to tell our IntelliJ that these two are completely different IntelliJ modules. Okay, so what we can do is we can go to our file, and we can go to our project structure here. Okay, and now here we can click on our modules. Okay, and here we can add this one. Okay, and we can point this one to our this module one. All right, you can create, you can click OK and next. Okay, next. Okay, now next. All right, so we can create this one. Now we can import second one as well. Next, next. We don't have any libraries, right? And now what we can do is apply and okay. All right, now we have still same issues. Our IntelliJ thinking somewhere our src folder, that was our previous structure, right? In our YT. So what else we can do is go to project structure, and we can remove this one, or we can remove this module. All right. No files will be deleted on disk. You can remove this one. Apply and OK. Module is not in dependencies. So we can add this one on module com.1. Okay. Now we are good. Okay. Now we can proceed with our step one. Compiling. Okay. What is that? Is declared in module which does not export it to this one, right? So now we are not exporting this one, right? So we will be getting one error. So let's hide this one and also comment this one. I guess we will be good. You can compile. Okay, you can provide destination module 1, and now we have to provide our module info file reference as well. Okay, so module basically 1 module-info.java. Okay, so here we can write same thing, and we have to provide this reference now as well. We can compile this one. Okay, now we can do same thing for our module 2, but this time we have to provide here module path, not something like CP. Okay, class path, and we can run this one. Okay, Java out module 1 out module. Okay, now we have to provide, let's say we can provide our entry point for this module, and we can go with now home.2 and .2.api.main. Okay, this is our entry point. We can run this one and we are good. Okay, now what if you have imported this one, right? Okay, so if you try to do that, then you will get one compilation error, which is declared in module which does not export this one, right? And if you can't import this one, then you cannot use this one as well. So now you are this internal, this one is truly internal for this module 1 only. Okay, we can clear this one now. With modules we have true encapsulation. So with modules we can see that we cannot access anything that is not exported explicitly, and if you export this one here, exports, now you will be fine here. Okay, but we don't want to do that. Okay, so in this helper.java we have changed nothing, right? But still, after this module file, our Java enforces the boundary now. Okay, and our module system made this one internal, truly internal for this module. Okay, and also our IntelliJ also switches to this module system after we create this file. So we can see that. Okay, now the module info.java file, this one we call descriptor, and this one has its own mini syntax. It is not a regular class. It lives in its own file and declares the module's boundaries. First, you can define your module name. Okay, usually we match this one with our sources root package. Okay, and then dependencies, what this module needs. Okay, requires this one, this one. Then exports, which packages are visible to other modules. Let's say this one, right? And this one is not exported, so it stays hidden. Module names follow the reverse domain convention. Similar to packages, a common practice is to name the module after its root package. Okay, in our case we name that com.1. Okay, okay, now next one is the requires directive. declares a dependency on another module, the compiler and runtime verify the dependency exists before your code runs. Okay, so let's say your module requires this one and you mark this dependency as transitive. Okay, so this one will be re-exported to dependents. Okay, so this one will be useful when some other module requires this module, right? Then that module or that dependent will get this dependency automatically. Okay, that module don't have to write this kind of syntax. Okay, again, this one is one use case for our transitive keyword. Okay, or directive from requires X, meaning this module depends on module X. Okay, both compile time and runtime. Then requires transitive X depends on X, and anyone who depends on this module also gets this re-exports, useful when access types appear in your public API. Okay, then requires static X. What is that? This one compile time only means required at compile time but optional at runtime. Okay, we can use this one for optional integrations that can be absent in production. Okay, or we can have some other use cases, something our annotations related. Okay, so annotations processors can also use this one. Okay, now we can move with our next one, which is exports directive. So we know that exports declares which packages are visible to other modules. A package that is not exported is visible only inside its own module. Okay, even if every type in it is public. Okay, qualified exports are useful for keeping a semi-public API visible to trusted collaborators without exposing it to the whole world. Okay, so we can do something like this. We can export one package to some trusted modules. Okay, so let's say here, if we are exporting this one, but let's say we want to export this one to java.base. Okay, now if we compile this one, because in this module 2 we requires this one, right? So will this compile now? Let's see, compile this one and we got this error. So internal is declared in module which does not export it. Okay, this one is different. All right. Also, we are getting error here that is declared in module which does not export it to module this one. Okay, because we are exporting this one to java.base. This can be any module. This one is one module. Okay, but we are not exporting this to our com.2. Okay, and if we do that com.2, then we are good here. So this one is qualified export. Okay, if we want to export this to some trusted collaborators. The next one is the opens directive. Frameworks like Spring, Hibernate, and Jackson use reflection to inspect private fields and call private constructors, right? With the module system, reflection is blocked by default, and this one is a big achievement. Okay, because Java had this reflection issue for a long time. Now, modules are strongly encapsulated. To let a specific framework reflect on your code, use opens. And we will see reflection later. Okay. So let's say we have this module, and if we want that reflection can access our some packages, then we can use this opens directive, right? And here we are not using that. In this, you can see we cannot access this class from reflection and its fields. Okay, and this one is very important. But let's say we want reflection enabled, then we can write here opens. Okay, and we will see reflection, like how can we access fields, methods, and classes by reflection later part of our series, right? What we can do is we can export as open. So this one will enable our reflection to our internal package. right? Opens is a runtime only grant. The package is not made visible for normal import and method calls. The compiler still rejects those, only reflection is unlocked. And if you still try to import this one in here, okay, you will still get error. Does not export to this one, okay. Now next one is services, provides and uses. Modules can also declare that they provide an implementation of some service interface and that they use one. This is JPMS built-in plugin system, replacing the older service loader configuration files. So let's say we have one module that declares the interface, okay, export this one. Module that uses this service, okay, we can have consumer requires this one and uses this, okay. Now module that provides an implementation provides with this one. So at runtime, our the service loader dot load this one returns every implementation provided by loaded modules. This is how extensible systems such as our build tools, IDEs, or application servers discover plugins without hard coding dependencies. Okay. Okay. And usually we don't focus on that part. Okay. So we can skip this for now. Next one is building and running a modular application. Okay, so now we know that our JDK is modular and our entire, let's say, Java development kit is now split into modules. Okay, and we will see some common modules here, but this one, building and running a modular application, we have seen these commands. The module path replaces the class path. Okay, we can use this one instead of this CP to tell the tools where to find modules. Okay, that's fine. Run the application, out, module, this one. Okay. The shorter forms P and M are equivalent to this module path and module. So we already have practiced these commands. So let's move forward and let's understand some JDK modules. Since Java 9, the JDK itself is a collection of modules. You can inspect them with, you can list your modules. Okay, so Java list modules. Let's see what will happen here. Okay, so you can see here we have base, compiler, okay, data transfer, desktop. We have here SQL, all right. We have here transaction, okay. We have here, okay, so we have some NIO, random, right. So we can clear this one, and also we can we can get to know some more about any particular module. So describe module java.sql. You can do that as well. What it exports, what it requires, right? So everything is built on modular design. A few of the most commonly used JDK modules. First one is java.base, and this one is implicit. Core language and utilities, implicit required by every module. And we don't have to write something like require java.base. This one is automatically imported. And then java.sql, JDBC, logging, and HTTP, and desktop. Okay. You never need to require java.base explicitly. It is automatic for every module. The way java.lang is auto imported for every source file. Okay. All right. Now next one is jlink, minimal runtime images. Because the JDK is modular, we can assemble a custom runtime containing only the modules our application actually uses. And we have this tool that does it, right? So we can create our custom runtime images, right? So let's say we have this module path. Here we can find and add modules. Output we want here, right? Then the output is a self-contained directory with a bin and Java executable. because it includes only the modules our app references transitively. It is often a fraction of the size of the full JDK. Okay, for containerized deployments, this is a huge difference, right? For Docker deployments, where we need, let's say, smaller images for faster deployments, then this can help definitely. This can reduce an image from hundreds of MBs to tens. Also, this can be used in our embedded systems where we have very limited storage. Also, some desktop apps so that our users can download um, less data, right? And they can use more efficiently. Now, we have one difference between modules and packages. So you can take a look into this table. We have groups, classes, and interfaces. Then module, this one is one top layer on this one package. So here we work with mostly packages. And encapsulation, every public type is visible everywhere. Only exports and packages are visible outside. Okay, even if you are not exporting, then even reflection cannot access unexported packages. Okay, then dependencies, implicit whatever happens to be on the class path, and explicit declared with requires. Descriptor none, here we can have this file. Now reflection always allowed, blocked unless package is opens. Okay, so this one is very important, reflection. We have used our exports directive, right? And also we have seen our opens directive. So if you are using just exports for any package, then we are making basically its public types accessible at compile time and runtime to other modules. But for reflection, our reflection by default or automatically does not enabled, right? For deep inspection, let's say for non-public elements, right? And if we need to allow reflective access, let's say for private fields or methods, then we must explicitly use this one alongside with our exports directive. Okay. So our opens directive allows some deeper reflective access to all types in the open package, right? So basically we need both directives. Exports makes our public types available to other modules, okay, at the source and runtime level, but okay. Now our next one is, should we use modules? Modules are most useful for large applications where we want to enforce architectural boundaries, okay? Libraries that want to hide internal packages and deployment sensitive context where shipping a smaller runtime image matters. Summary, you can take a look here.